Hello, I'm just going to talk you through gel electrophoresis of DNA. We can't do this in school because it is just so expensive. So gel electrophoresis is where you have a gel. Now this is a side view, but here we have a whole layer of gel, and the DNA can actually move through the gel. The DNA fragments of different lengths will move through the gel. So I'll talk you through the process, but first of all, if you just look, here we have, this is the apparatus that you would use. So this is the gel, and there you have a little well where you put the DNA. The whole thing is surrounded by a buffer solution, and that stops any enzymes being denatured, which is really good. At this end of the electrophoresis kit, you have a cathode, and remember that a cathode has a negative charge, and at this end you have an anode, which is a positive charge. Now if you look at the word DNA, there's an N in the middle. DNA has a negative charge, and it is actually due to the fact that DNA contains phosphates. So if you have DNA sitting in the gel here, the negative DNA will be attracted to the positive anode, and so the DNA fragments will start to move through the gel towards the positive anode. So remember, this is a side view. So the DNA that you're investigating is treated with restriction enzymes. They recognize a specific base sequence, and they cut the DNA into lots of different fragments. That DNA, all the fragments, are then added to a well on the gel. Now, the wells are actually created, the gel is poured, and then a comb is put. So if you think about it, it's like a fork is put into the gel, and then the gel is poured over the fork, and then the gel sets. And once the gel has set, the fork or the comb is removed, and you're left with these wells in the gel. So the comb is removed when the gel has hardened, and a little well remains. So once you have the gel set up and you've got your wells, the whole setup is covered then with this buffer solution, and there needs to be a lid to stop evaporation from the setup. So what happens next? A small electric current then flows through the gel, and it flows between the cathode and the anode. The current flows in a buffer, and the current flows through that agarose gel. The DNA fragments then, they are travelling through the gel, so they are negative and they're being attracted to the positive anode. And they travel at different speeds and distances, and it depends on the size and the charge of the DNA fragments. So fragments which were more negative would move more quickly. Fragments which are smaller will move further through the gel. So when the DNA has moved through the gel, all of the fragments have moved, the current then is switched off. Now at that point, the DNA will not be visible. So to make the DNA visible, a dye is added, and that dye lights up under a UV light. So then a UV light is added, and that reveals the DNA bands. So we studied this. This is how genetic fingerprints are actually produced. So this is a little bit more detail. Okay, so different DNA fragments then will appear in different positions in the gel, and then it's made visible with UV light, and that will give you your genetic fingerprint.